Hello, this is Information Service Engineering, lecture number 1, Natural Language Processing. In this part of the lecture, we are going to talk about NLP techniques and challenges. So let us start. So the very first technique known when we want to cope with a text in natural language is called text segmentation. So let's have a look on the right side of this slide. So this is the front page of a newspaper. Let's say we want to build an algorithm to process and make sense and understand what is there in this page. If we go from the first shot for everything that is there in the page, probably we are going to end up with not such an efficient or correct anyway answer. Since we see that we have here headers, that they are in larger fonts, they are underlined, we have pieces of text that they are really close to each other and they refer to completely different topics. So here the idea is that it's meaningful to split this sentence or this text, to segment it into units. Those units might be sentences, sections, or paragraphs, depending on the application. And let's see what happens when we want to do sentence splitting or sentence segmentation. So in this technique, we want to split a sentence, to split a piece of text into sentences. This might be based on cues like periods, exclamation marks, question marks, etc. So, on the left part of the slide, there is the input in a sentence splitting or sentence segmentation algorithm, and in the right part of the slide, there is the result with the different sentences splitted based on the period marker. If you notice, in the third sentence that we have as a result, there is the abbreviation US, where there in the US, there is the period marker, but the sentence splitting algorithm was smart enough not to split the sentence after the letter U. That is because the modern sentence splitting algorithms, they cope with this problem using classification algorithms, which are responsible to identify if the period marker defines the end of the sentence or is part of an abbreviation. And in order to do that, usually they make use of abbreviation dictionaries. So then it comes the tokenization technique. So here the idea is that we want to split a stream or a piece of text into different tokens. The tokens might be words, phrases, symbols, or other meaningful elements. Again, here we have an example of a famous tokenizer, where we gave as input a piece of text and then the output is a list of tokens. What I wanted to point here is that the period character is kept there as a separate token because it is useful and carries information for later steps like parsing, for example. Then it comes the part of speech tagging or POS tagging as it is commonly known. So here the idea is that we want to mark or label words in a piece of text to the corresponding particular part of speech for each word based on both its definition and its context. So here again we have the input and the output of the part of speech tagger. Depending on the application, there are different parts of speech that they are used, but the most commonly used are those like noun, verb, article, pronoun, etc. So part of speech tagging is rather important since it brings a lot of information regarding the word and the neighbor words. Since it is really important to know if the word is a verb or a noun. That tells a lot about neighboring word and about the syntactic structure of the sentence. So that is because that's why it is used in applications like discover named entities or other application information extraction. And then it comes the parsing or syntactic parsing. Here the purpose is to analyze a part of text or a string of symbols that they conform to the rules of a predefined formal grammar and build a syntactic parse tree of that input sentence. So here on the left we have the syntactic parse tree of the sentence Neil Alden Armstrong was an American astronaut and the first person to walk on the moon. You see that first we start with the root, which denotes the root of the tree, and then usually in most of the grammars it comes the character S, which denotes the beginning or starting of the sentence. Two of the main components that they are almost in every grammar is the noun phrase, which is abbreviated with NP, and the verb phrase, which is abbreviated with VP. Noun phrase is a sequence of words with which they surround or come after one or more nouns, while verb phrase might be, in some cases, it is a verb followed by another noun phrase, which is the case here in the right part of the slide in the smaller example that we have. Parse trees now are directly applied in applications like grammatical checking, since if we want to parse, we cannot parse a sentence and produce the parse tree of a sentence, that is it is highly possible that there are grammatic errors in this sentence. But more than that, parse trees are the intermediate step to go to the semantic analysis of a sentence. That is why they are used in applications like, for example, question answering. And then it comes the named entity recognition. So here the idea is that we want to locate and classify atomic elements in a sentence into predefined categories. These categories they are like names, persons, organizations, locations, times, quantities, etc., based on the application we want to design. So here we see that the input might be a couple of sentences or more, and then the output is the same as the input, but with the parts of the sentence labeled according to the class or category that they belong. So for example, here we see that Neil Alden Armstrong, it is a person, while August 5, 1930 is a date. And then the next step is the named entity resolution or word sense disambiguation, as it's called. So here we want to find the exact meaning of an entity and not only to which category it belongs. So here we want actually to link a piece of text to the corresponding entity which is already defined in a knowledge base. And this is what we do in this example as well. So we see here that Neil Armstrong is not just a person, but it's directly linked to the actual entity of Neil Armstrong to Wikipedia, as it is the case here. And we can all see how much information it brings, this linking part, so it is extremely useful in any type of application, especially in question answering, for example. And then it comes the semantic row labeling. So here the purpose is that we want to extract triples of the form subject, predicate, and object from a sentence. So we already know what is a verb in a sentence, which probably we know already from the POS tagger. But then, knowing where is the verb now, we can find out what is the role of the other components in a sentence. So we can then define what is a subject and what is an object, or maybe an indirect object in the sentence. And that brings a lot of information and helps us actually make sense of the meaning of a sentence. And by going towards the challenges that we face when we want to cope with a text in some natural language, we start with paraphrasing. So let's see what is a paraphrase actually. So a paraphrase is a restatement of the meaning of a text or a passage by using other words. It comes from the Greek word paraphrasis, which means additional manner of expression for the same thing. So let's see some examples and realize what exactly means. So the first example says that Google bought YouTube. So the paraphrasis of this sentence is Google acquired YouTube. So there are two sentences with almost or exactly the same meaning, but expressed in slightly different way, using different words. So the one is the paraphrasis of the other. And then we have, when will my book arrive? Which is paraphrased to, when will I receive my book? Exactly the same meaning, but slightly different expression. And then we go to the ambiguity. Ambiguity is probably the highest challenge we face when we cope with natural language text. So What does it mean actually? It means that one word or one sentence can have different meanings, given that we always talk about the same language. So let's say that we talk only about English. So one word in English can have different meanings. For example, we have the word jaguar. So jaguar might mean the famous car, or the wild animal, or the operating system. Or then again we have an ambiguous sentence like the door is open. To which door do I refer? We don't know, it is ambiguous. Or we saw her duck. What does it mean? That we saw her animal, her pet, or we saw her dive? Again, ambiguous. And there are different categories in ambiguity. The first is called phonological ambiguity. So here the idea is that words which sound the same or exactly the same might have different meanings. For example, we have the word weekend and the words weekend. So if I don't make a larger pause between the two words week and, they sound probably exactly the same as weekend. And you will be surprised to see how many of those examples exist in our real life, and we use the whole time and probably we don't realize. So in the right part of the slide, you can find some of those examples. And then we continue with a syntactic ambiguity. So here we have the situation where a sentence might be interpreted in more than one ways due to the ambiguous sentence structure this time. So the structure is ambiguous, and then we might have different meanings of the same sentence. This is also called amphiboly or amphibology. And let's see an example. So we have the sentence that says, he saw the man on the rooftop with a binocular. What does it mean? That he saw a man on the rooftop using a binocular, or he saw the man on the rooftop where the man had the binocular. It is ambiguous because the structure of the sentence is ambiguous. And then it comes the semantic ambiguity, where is a situation where a sentence might contain one or more words with different meanings, and then the significance of the sentence is highly dependent and changes dramatically depending on which meaning is intended for those ambiguous words. For example, the astronomer loves the star. What does it mean? That the astronomer loves one star in the sky, or that the astronomer loves a celebrity? Well, we cannot really say. Probably, I would think that, yeah, he likes a star in the sky since he's an astronomer, but yet again, we cannot tell for sure. And then last it comes the referential ambiguity. So here is the analysis of the coherent sequence of sentences which might contain those referential ambiguities. For example, we have the sentence that says, Alice understands that you like your mother. Till here everything is fine. But then it comes another subsentence which says, but she, and then where does this she refers? Does it refers to Alice or it refers to your mother? This is referential ambiguity. So up to now, I hope that we all agree that natural language is highly ambiguous. So as one famous quote of all these famous linguists like Ferdinand de Saussure says, I'm a linguist, I love ambiguity more than most people, which is really funny since it's highly ambiguous. It's a really highly ambiguous sentence. What do they mean? That they love ambiguity more than they love people? Or that they love ambiguity more than other people love ambiguity, since they are linguists anyway? Well, we don't know. So yep, in order to cope with all these problems, especially for ambiguity, we need to consider context. So we are depending on the context in order to make sense and have the correct meaning of a sentence. So sometimes the meaning of a sentence depends on the people present. So for example, for the sentence, how far is it? It depends. Do we understand miles or kilometers? There might depend on the social context. For example, for the sentence, that was bad? Well, what do you define as being bad? There might depend on the location, like play some song or some instrument upstairs. Well, if I am in the ground floor, upstairs might mean already the first floor. But if I am in the third floor, well, definitely fourth and higher. Then it depends on the time of the day, for example, because if we have the sentence, let's go eat, well, what are we going to eat? Breakfast, lunch, dinner, depends on the time. And then depends also on prior sentences. For example, the third one, Well, that means that we already mentioned at least 3 points up to now, and we refer to the third one, but this is in a previous sentence, so we are dependent on prior sentences. And then more challenges they make our life more difficult when we have to deal with different version or natures of language, which might be slang, jargon, humor, or sarcasm, completely different versions of language. And last, when we might also have mistakes, like spelling mistakes or grammar mistakes, or even things that they are not wrong, but they are newly created, like newly created abbreviations that we've never seen before. So we have to cope also with mistakes and then move to other challenges like ambiguity, as we already discussed. So yes, up to now we've seen famous techniques in NLP and challenges we face when using natural language. And next we are going to discuss linguistic basics one should definitely know when wants to build a new application in NLP.